Alright guys, today we are going to be starting up on 1.3, Introduction to Angles. Our learning target for the first part of today will be collinearity, betweenness, and assumptions. So those are the topics that we will be covering in this first video. In the second video, the part B of this, we will be covering the second learning target. I can solve problems involving straight angles and bisected angles. So let's go ahead and get started on our first learning target, collinearity, betweenness, and assumptions. So, first off, we have this problem. I just want to run through it real quick. This problem tells me angle TRS is a straight angle. So I can go ahead and draw that on my diagram. Angle TRS, this blue line here, that's a straight angle, which means that we know it's equal to 180 degrees on both sides. So both sides are equal to 180 degrees. We also know angle TRX, so T to R to X, this angle right here is 90. It's a right angle, so it's 90 degrees perfectly. Well, if this is 90 degrees and the full thing is 180, that must mean that this other angle over here is 90 degrees. So these are both 90 degrees, and then the full thing is 180. Now, I know angle TRS is equal to 2x plus 5, so I can go ahead and write that. 2x plus 5y equals angle TRS. Well, angle TRS is our straight angle. It's 180 degrees. So I can set this equal to 180. As for my other information that they give me, the other information that they give me is angle XRS is equal to 3x plus 3y. Well, angle XRS is this green angle here. So I have 3x plus 3y is equal to angle XRS, but that's a 90 degree angle. So that is equal to 90. Now at this point, we're going to go ahead and jump back into what we used to do in Algebra 1, and we're going to choose if we're going to use elimination or substitution here. Now, I'm going to go ahead and use elimination myself, so I want to get my coefficients in front of the x value to be the same number. So what number would be easiest for these both to be? Well, that's easy. I want them both to be the number 6. So what can I multiply the top equation by to get my x value, the number in front of my x value, to be 6? 3. So, and for my bottom equation, to get this 3 to become a 6, I need to multiply by 2. So we do just that. So, I multiply my top equation by 3, because again, I want to get these two coefficients to be the same. This 2 and this 3, I want them to be the same. When I do that, I multiply everything in this equation by 3. So this will give me 6x plus 15y. So again, 3 times 5y gives me 15y. And then 3 times 180 gives me 540. On bottom, I multiply the 2 all the way through. 3x times 2 gives me 6x. 3y times 2 gives me 6y. And 90 times 2 gives me 180. From here, now that they are the same exact number, I'm going to go ahead and eliminate these. So to do that, I'm just going to take both equations and I'm going to subtract straight down. When we do that, our x's will cancel. 15y minus 6y will give us 9y. And then 540 minus 180 will give us 360. Dividing both sides by 9, we end up with y equals 40. So that's our y value. To find my x value, I take that 40, I plug it back into either equation for y. So I plug it back in for y. When I do that, I end up with this equation over here. 3x plus 3 times y, which is now 40, equals 90. Well, 3 times 40 gives me 120. And when I subtract that from both sides, we're left with 3x equals, well, 90 minus 120 gives me negative 30. So 3x equals negative 30. From here, divide both sides by 3. The 3's will cancel. Negative 30 divided by 3 will leave us with negative 10. So x is equal to negative 10, y is equal to positive 40. Those are our two answers there. All right. And now that we've answered our question, let's go ahead and jump into some definitions. So it's important before I move on that I note that x and y are not angle measures. They're not the angle measures that we're dealing with, but they're the variables within the angle measures. So keep that in mind. These variables are not actually angle measures here. They're just variables. They're just unknown numbers. So for our definitions, we need to know the definition of collinearity. all collinearity means is that they are on the same line. So co will mean that they're the same, and then linearity will be they're on the same line. Now, points that are on the same line are collinear. Points that do not lie on the same line are non-collinear. So for it to be collinear, I should be able to draw a line through all 3 points, and it should intersect all 3. Our lines cannot curve, they cannot bend, they cannot do anything like that. They just need to be straight. So if I look at line ED, for instance, in the second diagram, it will not go through point F. And in fact, if I draw a line for each segment here, we can see that none of these lines will contain all 3 points. They each contain 2 points only, right? 2 points here, 2 points here, or 2 points here. So we see that when we have a non-collinear figure, when we have 3 points that are not collinear, they create a triangle. This is the triangle inequality theorem that we'll cover in just a bit. So if there's 3 non-collinear points, it creates a triangle. If there's 3 collinear points, it creates a straight line for us. So that's the big difference there. Now, again, all 3 points are not on the same line together. That makes it not collinear, non-collinear. All right, so in this diagram at the right, we're just going to go ahead and go through this. So points R, S, and T are collinear points. We can see that because R, S, and T all lie on the same line. Next up, points P, O, and X are also collinear. So points P, O, and X, they all lie on the same line as well, making them collinear. And then lastly, we have points M, O, X, and Y. Those are non-collinear points. So if we look at this, M, O, X, and Y, well, Y, X, and O are all collinear, but point M is not. So again, all points that are stated must either be on the same line or they're no longer collinear. It can be 6 points, 7 points, however many points that you need. They must all lie on that same line for it to become collinear. All right. With that being said, we're now going to talk about betweenness. So if something is said to be between something, there's 2 things on either side of it. So if I have 3 points and they're all on the same line, that's very important for betweenness. They must all be collinear points. So I have 3 points all on the same line. I can say that point T is between points A and R, because again, point T is right in the middle. Now, if I look at this red diagram over here, again, these points are not collinear. X, Y, and O, they are not collinear points. So point O is no longer on line XY. Now, if it's not on the line itself, I cannot say it's in between. So again, if it's on the line here, yes, that's fine, it's in between. But if it's off the line, then it's no longer between. So again, if it's collinear, one of the points will be between the 2 other points. All right, next up. For each diagram, tell whether X is between P and R. Answer yes or no. So for this first one, we have P and R, then we have X right here. So is X in between P and R? Absolutely. They're all on the same line, they're collinear, so therefore X is between points P and R. For our second diagram, we have points P, R, and X. If I were to draw a line between points P and R, would X be between them? No. X is way over here. If it was on the line segment itself, then absolutely. Then lastly, we have angle ROP. If I were to draw a segment between R and P, would X fall in between? No. X does not lie on that line, so therefore it is not between those points. So again, betweenness relies on being on the line itself, and then also being between 2 other points. All right, now we're going to draw a diagram in which A, B, and C are collinear, A, D, and E are collinear, and B, C, and D are non-collinear. So I go ahead and I start this off by just drawing my first 3 points that are collinear, A, B, and C. They all lie on the same line. Next, we're going to go ahead and draw A, D, and E that are collinear. Now the main thing here is that A is shared. So A is shared by both lines. I'm not going to redraw point A. It's already here. So I need to draw another line with point A on it that also has D and E. So here it is, my red line. Lastly, we just need to make sure that this is true. Points B, C, and D, all three of these points are non-collinear. Well, let's see. B and C lie on the same line, meanwhile D does not. So that's in fact true. All three need to be on the same line for them to be collinear. Since they do not, those 3 points are non-collinear. All right. Last couple of things that we're going to talk about in this video. The triangle inequality theorem, you heard me say this earlier. The triangle inequality theorem says that if I have 3 points, only 2 things can happen. The first thing is that those points are collinear, which means that it will create a straight line. So if all 3 points are collinear, it creates a straight line for us. The other option is if they are non-collinear, meaning the 3 points are not on the same line. If that's the case, it would create a triangle. So again, collinear, it creates a line. Non-collinear, it creates a triangle. The last thing I want to talk about is assumptions before we finish off today's lesson. Assumptions on diagrams. So these are all very important, especially as we move towards proofs. There are certain things that we can assume based upon a picture, and there are certain things that we cannot assume based upon a picture. The first one that we can assume is straight lines and angles. So if I were to see a straight line, I can automatically assume that's 180 degrees. And if it looks like a straight line, I can assume it's a straight line as well. The other thing that I can assume is collinearity. If I see 3 points that are all on the same line, I can assume that those are collinear points. I can also assume, if I label these as A, B, and C, I can also assume betweenness. So I can assume that point B is between points A and C. Then the last thing that I can assume is the relative position of points. So where they are at in relation to each other. Obviously, with this diagram here, I'm not going to say that point C is between A and B, because based upon their relative positions where they're at currently, it's actually B that's in the middle, not point C. So again, it's all about where they are relative to each other. We can assume that based upon the diagram. Things we cannot assume from a diagram, though, equally as important, because I don't want you assuming stuff that you cannot assume during a proof. The first thing is right angles. Unless I have a box here in the middle, I cannot assume that this is a right angle. It could be 89.99. I can't assume it's a right angle unless I see a box. As soon as I see a box, I know that that's 90 degrees, but if there's nothing there, I can't assume anything. Congruent segments. I can assume congruent segments as long as they are shown as tick marks. If they look to be about the same, such as A, B, and BC here, I cannot assume that those are congruent unless they actually have the congruency marks here. If they have that, then they're good to go. The same thing can be said with angles. If I have 2 angles that look the same, then I cannot assume that those are the same unless I see congruency symbols. So congruency symbols are key for me to assume that segments or angles are congruent. That's what I need. And then lastly, the relative size of segments and angles. If I have 2 segments that don't really look like they're the same length, however, they have congruency symbols that show they are the same length, I can assume that they're congruent. Not everything will be drawn to size in this class, so it's very important that we can assume these things based upon congruency marks alone. So make sure that you guys do know this. It will be very important to know for the proofs that are coming up, but I wanted to make sure that I covered all this. In the second video, we'll go through some extra practice with this to make sure that we're good to go. Thank you guys for watching. If you need anything, please let me know, and have a great rest of your day.